Hello students. So I'm back with the next video which will explain you what do you mean by activation function and what is the role of activation function in neural network and what different type of the activation functions we can use while designing the neural network. Now let's see the definition of the activation function. Now what our neuron is doing, we will give input, we will assign some random weights, then input will be multiplied with those weights and we will have weighted sum. Then that weighted sum we will add to bias. This is only neuron is doing. But what is next? When your weighted sum is added to bias, whether that will be converted to output or not, means whether that neuron will be active in the next layer or not, that decision is taken by the activation function. Means input will be converted to output only because of activation function. So the main task of the activation function is transforming the given input to output, and because of activation function only we can take the decision whether a neuron can be fired or not. Fired means what? It is active in the next layer or not, whether it plays role in next layer or not. Okay. So, what is the main purpose of it? To convert an input signal to a node in artificial neural network to an output signal. Okay. So, here, the first activation function that we can see is a step function. Now, what the step function is doing, we have to give some value threshold. If your y, what is y now? Weighted sum plus bias is greater than threshold, then only you will assign the value 1. Otherwise, you will say the value as 0. So, just like a step will be formed, either positive or negative. Okay. There will be a positive step and there will be a negative step. Okay, that's why it is called as a step function. But what you can observe here, the possible values are only 1 or 0. Means only activated or not activated. These are the two outputs we are getting. Means yes or no. Means such type of activation function is capable of classifying inputs only in two classes. Means it is useful only for binary classifier. But if my requirement is to divide my input data in more than two classes, means I want to go for multi-class classification, then in that case, I can't use such a simple activation function. For that purpose, I need more complicated function like sigmoid function. Now, sigmoid function is not putting its center in 0. Okay. And the center is non-zero. Now here you can observe that the center is 0.5. Okay. And it is trying to form a S-like curve. Means when your input is negative, then it will try to module your output in positive values that you can see. Now here, it will squashes the neurons pre-activation between 0 and 1. Means you will get your output only in between 0 and 1. You can see the S-shaped curve only in between 0 and 1. It will not go below 0 and it will not go above 1. Okay. That's why as it is not going below 0, it is always positive and it is bounded by your 1 and it is always increasing, trying to give a shape like S. And this is the most common activation function we use in neural networks. So don't forget the formula of sigmoid, that is g of x is equal to 1 divided by 1 plus e raised to x. Now, what is your x? Your weighted sum plus bias. Okay, what is your x? Your weighted sum plus bias, not your direct x input. Weighted sum plus bias, that will be your x. Okay. Now, another type of activation function is a tanha, which is just like a double of your sigmoid. Okay, just you have to multiply it by 2 and minus 1. Now here, what it is trying to do, it is not limited up to 1. Means it can be positive or negative. That's why the range is here minus 1 to 1. So this is also bounded means you cannot go below -1 and you cannot go above 1. Okay, and it is also strictly increasing. So this is the formula for Tanha tangent. Generally, it is what? Hyperbolic tangent. We call it as a Tanha. Okay, that is the formula you have to remember. Okay. Now, ReLU. ReLU means what? Rectified linear unit. Now, whenever you want, your output should be strictly in the positive region, just like our AND gate. If both the inputs are positive, both the inputs are 1, then only I will get the output for AND. If any one of the input is negative or both the inputs are negative, I will not at all activate my AND output. Then in that case, your ReLU will be the best activation function you can use. Now, what it is saying, you have to consider the maximum in between the 0 and x. Now, as I'm considering the maximum between 0 and x means, I will always keep my output in the positive region only. Okay. Now, here what you can observe, you are never going below 0. Means never you are going for negative values. It will be always non-negative. Okay. And it is not upper bounded. Means there is no bound for your positive value. Any positive value that you can consider, and that will be not limited. Okay. Now, but what is the disadvantage? There may be neurons with the sparse activities. Sparse activities means what? If your neuron is generating the output that is negative, then you will convert it to the 0. Yes or no? You will convert it to the 0. If more number of the zeros are there, then you will call it as a sparse one. Okay. Now, in ReLU, when you are going for the rectified linear unit, there is one disadvantage that is called as a dying ReLU problem, a very famous problem. Now, listen, when we are considering the gradient descent, now gradient descent means what? We are trying to find out local minima and global minima. Now, whenever I'm going for minimum value, then I may have decreasing slope or may have increasing slope. Now, whenever I'm having decreasing slope, means I may need negative values. Okay, but my ReLU is not at all allowing me the negative values. Whenever I get negative values, it is converting it to the 0. So because of this 0, my actual negative value is dying. So that's why this is called as a dying ReLU problem, because my actual value is lost. It is converted into 0. I'm not getting my actual value. Actually, here what I want, the minimum value that I can consider for error in my gradient descent. But that minimum value is converted into 0. Okay, so that is a wrong transformation. That's why such problem is called as a dying ReLU problem. So in such cases, ReLU is not a good activation function. That's why it is expensive than your Tana and sigmoid in such cases. Otherwise, the computations are very less. Means just you will consider the positive values and the negative values will be considered as a 0. Now, for dying ReLU problem, you can go for the Tana or sigmoid function. Now, one more activation function is the softmax function. Now here, softmax function you are using for output layer, and whenever your classification is a multi-class classification, mostly it is used in the output layer only. Now it is making use of the conditional probability, means you have to find out the probability of C given X. So this is the formula that is used for the softmax activation function, and which is mostly used in the output layer of the multi-class classification. So these are all the activation function. The first one we have seen is a step function. Second one is a sigmoid. Third one is a hyperbolic tangent, that is Tanha. Then the next one is a rectified linear unit, that is a ReLU. The problem caused because of the ReLU is dying ReLU problem. And the last activation function which you will use in the activation layer is a softmax activation function. So this is all about the activation function. Now in next video, we are going to see a very important algorithm that we are going to use in a multi-layer perceptron network, that is a backpropagation algorithm. And the next video too, it will be based on the example of the backpropagation algorithm. So both are important for your career point of view. So, thank you.